Right. To try and draw this. Okay. Air, water, glass, air. Okay, so here n is equal to 1. The water, n is equal to 1.33. The glass, n is equal to 1.5. And here the air again, n is equal to 1. So this one here, this is, where's the water? Here. This one here is glass. Glass. Yeah. Water. That's air and that's air. Okay. Right, let me just put a line down here. This is the normal. Now if you look at the formula, sine theta 1 over sine theta 2, that's equal to n2 over n1. So if the n increases, the theta decreases.
Mm-hmm.
So what's the first angle? Comes in at 45?
35.
35. So because the n increases, this angle will decrease. So this is less. Okay. Right, now, because it increases, it...
decrease.
I think I need to draw this angle a bit more pronounced to try and... I know it's obviously not this big, but it'll help me draw it. So that's 35. Here, this angle here is less. Then it hits here. Okay, so what happens next? So this one... Where is it? Yeah, this angle is the same as that one, which is also, well, I won't write less. Less again? Oh, flip's sake. Lesser. Oh, this is looking disgusting.
More.
And then
Fly away.
decrease, so it gets bigger. So that... it's hard. So it gets greater. More. Oh, that's disgusting. Right, let's do some actual calculations. What is the angle of refraction as the ray enters the glass?
Calculate.
So, which angle is that they want now? As the ray enters the glass block. Does it mean, I think, this angle? Which we said is the same as this angle.
Why?
So, because of the alternate, yeah, the z. Right, so sine 35 over sine theta 2 equals 1 over 1.33. This gives me theta 2. What is this here? Do you have it? 25 sounds about right. 25? 25.
Oh yeah, the other thing.
Thanks for catching up. Determine the angle of refraction as the ray leaves the glass. So that's this angle here. So that means we need to know this angle, which will be the same as, oh, for flip's sake, this one here, which is this one here, which is this one here.
Sure.
Now please.
It's n2 over n1. It's 1
Didn't do.
over 1.
Okay, fine.
See, I help you.
Thank you. Now I've lost what I was thinking about. Which angle did I want? This one. From here to here. Sine theta 2 over sine 25, is it? 1.5 over 1?
Wait, you don't use 25.
You don't? Are you sure?
Because 25 is the incident into the glass, and then there's the eye.
So what angle do I use?
The eye. 25 is the eye into the glass. So it's
I have this backwards.
No, you have to find the eye.
For 1 mark.
I mean, 25 is the incident into the glass.
Let's draw this again. How many layers have I got? 1, 2, 3, 4, isn't it? Right. Now, don't distract me. So this one comes in at 35. So that's 35. Okay. Now I don't care if they ask me for it or not. I'm just going to work it out. So the next angle here, that's the one we already worked out, is it? So that's 25. Okay. So that will hit here, and this here is 25. So that's 25, and this is what I want. And this is glass, which is this last one is glass, isn't it? Now air, water, glass, air. So this is 1.5, and this is 3.3. Okay, so you have sine 25 over sine theta equals 1.5 over 1.33. Is that what I just said over here? No.
You found 25 already.
Well, if we open up the answers in the marking scheme, we can see if we're right.
Aha.
Aha.
22. So they are not the same.
Wait. Yeah, 22. Sorry, I drew it badly.
And then now they're asking for the angle of refraction and diffuse.
No, isn't that what I just did?
22 becomes I, and then the refraction.
Is that not what I just did?
What
No.
you've just done is that
It's the answer.
Is that 25 right, though?
No.
The 25 is the I. They're asking for the angle of refraction at this angle.
Hang on.
What you found.
Determine the angle of refraction as the ray enters the glass block.
That's what you found now.
25.
That's this one.
That's 22.
And because that's the same as that.
Yeah, but that's the I as it's entering the glass. They're asking for the I.
Air, water, glass. Okay.
Oh.
Determine the angle of refraction as the ray enters the glass block.
25 is the angle of incidence as it's entering
Yeah.
the glass.
But is the 25 even right?
No, it is the incident for 25.
The 25 is from this one, and that's the or from this one.
Yes.
So sine 35 over sine 25 should equal 1 over 1.33.
Yeah.
If that's right,
1.33 over 1.
and okay, well let's just double check it, okay? Sine 35 divided by sine 20. Okay, round an error, but that seems fine. Okay, so I'm happy that that's right, and so that's right, and this is right. But I'm not even finished.
That's part 2.
Determine the angle of refraction as the ray leaves the glass. Ah, so now I need to do it again.
Yeah.
Sine 22 over sine, we'll call this angle here alpha or something. Sine alpha equals n2 over n1. Flip's sake. 34.
By 1 now.
Ah, that was a terrible question. Terrible. Absolutely horrible.
Be confused.
More than a bit. Terrible. Absolutely terrible. Can I close it? I've just closed it. Okay. Alright.
In a working scene, you're saying that the angle you get at the end should be the same as the first angle you incident. When we are close, how is that?
Round and error. Oh. Are they trying to say there's some kind of symmetry here? If you go air, water, glass, air, then the angle exit has to be the angle entered? Yeah. But I think it depends on the water and the glass's refractive index. Because,
They are roughly the same though.
no, they're not actually. Monica, could you type in on the calculator? Oh, I can type it in here. No. You see how the refractive index of glass is 1.5? 1.5 is 3/2, and the water is 4/3. Now, it's not clear what the relationship needs to be so that the angle is the same at the end as at the start.
If it was 1, it would be the same.
With what?
4/3 times 2/2.
4/3 times 2/2 isn't 1 though. Um,
2a divided by 2 is 1.
see, the No, it doesn't. I'm trying to figure out how you can know it will be the same. Air to water, water to glass, glass to air. No, it's not. No, I was trying to do the path. So the first one's air to water, which is 1/. And the next one is water to glass. And the last one is glass to air.
Oh!
No, there's nothing special there. That has to happen. Because this is, yeah. Sean and Lee, and you, what we're trying to figure out is if in the picture here, oh, it's gone now, the angle at the end, when it comes out at the end, is 35. The same angle it enters at. We're trying to work out if that's always the same. Or let's just work it out together. It can be fun. Let's see what happens. So rather than saying air, water, glass, and air, we'll just say N1, N2, N3, N1. Yeah? Okay, so for the first one, you have how many layers? Air, water, glass, air, is it? Air, water, glass, air. So we'll call this one N1, N2, N3, N1. Yeah, okay. Now we need to put in angles, so we'll call this one, it comes in at here.
40.
No, we have to give it a letter. I'm not going to write the pad out. Okay. This one here comes in at theta 1. And here this will be theta 2. And here this will be theta 2. And here this will... Yeah, this will be theta 3. This one's theta 3. And this one's theta 4. And the question is, will theta 1 equal theta 4 if we have 1, 2, 3, 1? That's what we want to see. So let's see. And then if it's true, we'll call it the IFY theorem. Right, so we have sine theta 1 over sine theta 2, N2 over N1. And we have sine, so that's this one done. Sine theta 2 over, and then sine theta 3 over theta 4 and 1 over N3, isn't it? Right, so let's see, we want to try and put these together. Well, I think because we have theta 2 and theta 2 here, we could combine them. So this would be N1 over N2 sine theta 1. That's for N2. For theta 2. And here, you could do the same thing, couldn't you? Oh, sorry, I mean here, yeah, you could get N3 over N2 sine theta 3. And here, you could get N1 over N3 sine theta 4. That's equal to sine theta 3. These two are equal, because they're both equal to sine theta 2. And this one is equal to sine theta 3. So I could get here sine theta 3 equals N2 over N3, N1 over N2 sine theta 1, making these equal. But sine theta 3 is N1 over N3 sine theta 4. So this is N1 over N3 sine theta 4. Cancel 1, cancel 1. Cancel 3, cancel 3, cancel 2, cancel 2. Sine theta 1 equals sine theta 4. Therefore, theta 1 equals theta 4. Yes, so it should always be the same. So if you have 1, 2, 3, 1, then the angle in here must equal the angle out here.
Wow! Amazing.
It's quite
So
amazing.
the first one has to be the same with the fourth one, right?
Mathematically, it has to be. Yeah.
So it's just
So our answer is wrong.
No. That's fine. It's just we did much more work than we need to. It's only 1 mark. In other words, for 1 mark, you could have just said the answer is 35.
Oh.
Because
So
the
we-
equation-
Refer to higher function.
But does it make sense if we using like sine 25 over sine 25?
What do you mean?
Our answer is 22.
Because that's in the thing.
Yeah, that's all. That is very interesting. I've never seen. It's strange because it's like they expect you to know this fact as if it's some kind of well-known fact. But it's not something I've seen in a exam or syllabus or book before, that if you have 1, 2, 3, 1, the entry and exit angle is the same.
So I only try to say, just write
35.
theta equals 35.
Yeah. Very, very interesting.
Yeah.
Very, very interesting. You don't look happy, Andrew. You look very unhappy.
No, so if I change the material from glass to another material, is it still the same?
Yeah, it is. It doesn't matter that it's water and glass and air.
So, because I have a question.
Yeah.
If I use theta 1 instead of theta 3.
Theta 1.
Oh, no. N1 instead of N3. This N1 into N1, N1.
Oh, if you change it, yeah, say again, what is it?
N1 into N1, N1.
And one is just
This,
Oh, no.
and
Oh.
one is air.
Oh, yeah. Oh, yeah.
area. Well, no, if you look at N1, N2, N3, if you look at the formula, it didn't, like, I think what's most important is it's like different, the same as the first one. Yeah. But you might say, oh, could these be the same? Well, I guess they could, but then what's the point in giving them different names? So, you could have something else, and then the original. Very, very strange. You would never have, I thought there might be some requirement on the relationship between N1, N2, N3.
Is it kind of low?
Well, it is. It's a fact. We've just proven it. Theta 1 has to equal theta 4.
Low.
For sure. So interesting. Okay, let's see.
Oh.
What's next now? Double slit. Oh, the next one? Yep, okay, page 38 now.
Oh, yeah. I think this is
Okay. In Young's double slit experiment, the double slits are placed at distance 1.25 from the screen. The wavelength is 638 nanometers. The distance from the third on one side to the third on the other side is that. So that means 6s equals 13.5 millimeters. What's the D? Oh, this is fine. N lambda, S equals lambda D over D, so therefore the D equals lambda D over S, which will equal 638 times 10 to the minus 9 times 1.25 over 13.5 times 10 to the minus 3 over 6. That's the answer.
Teacher, what does that mean? The distance from the third?
right. So
Minus 3 to plus 3. Yeah? What's the answer, Monica? 33,
No. 3.54.
3.54 milli?
And then minus 4 meters.
Ah. Why don't you use prefixes? 354 micrometers. What's wrong with that?
Teacher, why you divided by 6?
That distance they gave you is from -3 to +3. You know you have your dots.
Yeah.
So they gave you this from -3 to +3.
Oh.
That's 6.
2, 1.
Oh, wasn't that bad. How far did you get yesterday with Connell? Yeah, so how far did you get? What did you do yesterday with Connell?
Two.
Did you do any waves?
No.
Lee, have you done many of the wave questions?
No, no, no.
Chu? Have you done many waves? No? Sean? Waves? Have you done many? Have you done any? Alright. So I don't want to continue doing these if you haven't tried them first. So I'll let you work on them for a few minutes. And then we can, well, later we're going to do maths. So I think next week we'll continue with the waves. Okay, but can you try them now? You can see that there's not many wave questions.
Yeah.
And this kind of tells you that it's not as common as fields or atoms in section A. I think this is because there isn't as much in waves to ask. I mean, Snell and Young, kind of most of it, nearly everything. So this is why there's a limited number of questions. Do you have the book? Yeah, okay, so try these for a few minutes. Let me save this.